Hi dear students, myself Deepak More and today I am going to teach you physics of standard 8, lesson number 6. Name of the lesson is heat transfer. As in the last video we learned about the introduction and effects of heat, and in the effects of heat we learn about the change in the temperature of the body, change in the size of the body and change in the state of the body. In that we learn many more definitions also. Now today is the time to learn about effect of temperature on a molecular motion. Then how the temperature is affecting the molecular motion of the body. As we are familiar about the molecules, the molecule whenever they are in a motion, that time they are possessing the kinetic energy, and it have the particular temperature with them. Though as temperature is increases, the molecular motion is increases, and as the temperature of the molecule is going to be decreased, the kinetic energy of the molecule is also going to be decreased, and the motion of the molecule is also going to be decreased. And at high temperature the molecules are very agitated, and when the molecules are agitated, this suggests that it has a limit. Though when the temperature is 0, that time the molecules are completely seizes, and the molecules are having the potential in them, but there is no kinetic energy with them. And in that case, whenever the molecules are completely seizes and the temperature is 0, though temperature at which molecular motion completely ceases, whenever the molecular motion of that particular body is completely ceases, that is known as absolute zero. That is known as a absolute zero on the Kelvin scale. On the Kelvin scale, and the temperature rather than and the temperature lower than absolute zero is not possible. The temperature lower than absolute zero is not possible. This is nothing but effect of temperature on a molecular motion. Now the next topic of the lesson is change of liquid into vapor state. As we know that whenever the liquid is going to be changed, whenever we are passing heat to it, that time the liquid is going to be changed from liquid to the gaseous or vapor state. Though whenever a liquid is changing from liquid state to a gaseous state at a particular fixed temperature, that process is called as a vaporization or boiling. As it is called as a vaporization or boiling, it means that to change a liquid into vapor, there are two ways. The two ways are by evaporation or by boiling. So by evaporation, it occurs at all the temperatures, at a room temperature, and by boiling, it is at a fixed temperature. So we will see the first one, evaporation. So now we will see the first one, evaporation. The evaporation is a process in which the change of liquid into its vapor at all temperatures from its surface is called as evaporation. Evaporation is a process in which the liquid changes from its liquid state to vapor state, but it is changes at all temperatures and it is changes from its surface is called as evaporation. If we have to give an example of evaporation, then we are familiar about the petrol. If we keep the petrol in an open surface, then we will notice that the petrol after some time we cannot see what is happening with that. Though in that cases of that petrol, the petrol whenever it is going to be contact with the air which is present in the surrounding, and the air is containing the temperature with that, it is at all temperatures. It will be low temperature or it will be high temperature. The petrol evaporates. And after some time we cannot see the petrol in a particular bowl or container. And this process is called as evaporations. The essential is what? Whenever we keep the petrol in a bowl or container, the bowl and container were open. If the bowl and container will be closed, then the process of evaporation will not occur. It will be there, but it will be very slow. It means that for a process of evaporation, the surface is must. The surface, open surface is must, and then only will be an evaporation. From this we can conclude that the evaporations mainly take place on the surface only. Means the temperature is acting on the surface and the surface molecules are getting charged, and because of the charge and their kinetic energy is increasing, and whenever the kinetic energy of the molecules of the liquid is increasing, that time they are starting to vibrate, and they whenever as the temperature will be increased, the vibrations will be increased and the kinetic energy will be increased, and as much more the kinetic energy will be increased, their bonding will be breaking, and as much the gaps between them is increasing, they are starting to move randomly, and they going to be turned from liquid state to the gaseous state, and this is how the evaporation occurs. Now the next topic is explanation of evaporation on the basis of molecular motion. As we are familiar about the three states of matter: solid, liquid and gas. If we will discuss about the solid, then the solid have the definite shape, and the spaces between them the solid. The spaces between the molecules of the solid is very less, and they are compactly packed. And the kinetic energy of the solid molecule is very less. The potential energy of the solid molecule is more. And if we try to break the solid molecules in the small pieces, it is very hard to break. But if we took liquid molecules and if we try to make a small pieces, it is very easy to make a small pieces. Why? Because the spaces between them of the liquid molecule is sufficient. They have the spaces in between them, and the kinetic energy of the molecules of the liquid is also more than the solid. So what is happening in these cases? When the liquid molecules are having the spaces between them and it have the sufficient kinetic energy, that's why the molecules of the liquids are free to move in their boundaries, and whenever the molecules are reaches to the surface, that time they are getting the sufficient kinetic energy, and the cohesive force of the water molecules are getting that surface molecules inside, and that is why whenever the molecules are at a surface, we can say that the liquid have a volume, it have the fixed volume. But if you will see in the case of gases, the gases are very free to move. It means that the spaces between them is very more. Okay, and the kinetic energy of the gaseous molecule is also more rather than the liquid and solid. And on the basis of that, the gases are free to move in their boundaries, or they don't have any boundaries. So that is why we can say that the gases do not have any fixed volume or shape. The water is also not have the shape, but in what we are pouring the liquid or the water, that particular shape it is continuing because it have the fixed volume. But the gaseous molecules don't have any fixed volume or it don't have any fixed shape. So by seeing this particular discussion, we can explain that the evaporation and the molecular motion. As we know that evaporation is a process which is turning the liquid molecules into the gases. So whenever the liquid molecules are present, and whenever we will see about the liquid molecules having the kinetic energy between them. Whenever the kinetic energy present in the liquid molecules, that time the molecules are vibrating at their positions and they are moving from one place to another place. Whenever they are moving, the molecules of the liquids are moving from one place to another place, that time they are colliding on each other, and whenever they are colliding on each other, that time the separation kinetic energy is also increases. Means the kinetic energy of the molecule is also increases. As much more they are moving, that much more kinetic energy increases, and the molecules are getting sufficient kinetic energy and they are going to be at the surface, and whenever they are coming to the surface, that time it is turning slowly into the vapor forms. And this is nothing but an explanation of evaporation on the basis of molecular motions. The evaporation process is depends on the temperature of the liquid, wind, humidity and surface area given to the liquid. Now we will discuss some points related to the evaporations. Means how the evaporation changes as there is a change in a temperature, as effect of blowing air on the rate of evaporations, effect of increase in area of surface on the rate of evaporations, effect of presence of humidity and cooling produced during evaporations. So we will discuss one by one. So the first topic is effect of temperature on the rate of evaporations. It means that if the temperature of a particular body or the temperature of the surrounding will be more, then the evaporation will be faster, and it will be less, then the evaporation will be slower. For example, if we took another bowl and we took that bowl and we kept in another room temperature in our surrounding, we notice that in the morning the evaporation were slow, while in the afternoon the evaporation is faster. Why? Because in the morning the room temperature were less, and in the afternoon the room temperature will increase because the surrounding temperature is also increasing, and because of that the evaporation goes faster in the afternoon. Now the next one is effect of blowing air on the rate of evaporations. Now how the blowing air is affecting on the rate of evaporations? As we are familiar about it, that whenever the air is blown from any body, that time the vapors which are present on the surface of that body is move away from it. That is why whenever air is blowing out from any surface, any liquid, it is kept in evaporation. Whenever evaporation is going on, and whenever the air is blown out or from the surface, that time the evaporation process will be faster. The reason is that because the vapors which are coming from the surface that are getting placed on the place of that particular first vapors. One of the best example for that is what? Whenever we are drinking a tea, then if we took a tea in a saucer, and when the tea is hot, that time we are blowing the air from the tea. Why? Because the vapors which are present on the surface of the tea are moving away, and again another vapors are coming on the place of that first vapors, and again we are blowing the air that is moving away, and this is causing that the tea is getting cool early. And this is nothing but second one, effect of blowing air on the rate of evaporation. Now the next one is effect of increase in the area of surface on the rate of evaporation. Now how the area is affecting on the rate of evaporation? Though as much more area is given to the evaporation, the evaporation process will be faster. As much more less the area, the evaporation will be slower. For example, if we took hot water in two containers, one is having small area, one is having bigger area, then the hot water which is present in a more area will cools early than the which one is having the less area. Why? Because the water is getting the more area surface, because the water is getting the more surface and area. That's why the evaporation process is happening at the most of the water, and that is why water which is having more area will cool early, and that is why we can say that as much more area the evaporation will be more. Now the next one is effect of presence of humidity. Now if humidity is present, then what is happening in the rate of evaporation? If there is a humidity near to the surrounding, that time the evaporation becomes slow. So what is the reason? Humidity means what? The air molecules which are in our surrounding that are present with the liquids, means drops of liquids, means the only airs are having the air molecules are having the presence of liquid in it, and because of that whenever the evaporation occurs, it wants air surrounding it. If the air is having the liquid molecules or a liquid is present in them, that time the evaporation will be slowed down, because the evaporations happens only when the when the vapors are going contacting with the air molecules, and the air molecules are getting that vapors in them and they are moving forward. If there is a humidity, the evaporation will be slower. Now the next one is cooling produced during evaporation. Now whenever evaporation is happening, that time the cooling is produced in their surrounding. What is the reason and how? As we are familiar that evaporation is slow process and it is takes place at a room temperature. So in the evaporation, whenever the evaporation is happening, that time the temperature taken by the liquid molecules to get the heat or to increase the heat in them is from the surrounding air molecules or from the surrounding temperature. That's why the area surrounding to that particular container is getting cool, because the molecules which are present in the liquid that are getting the heat from the surrounding air, and that is why the cooling produced during evaporations. Now the next one is boiling. The change from the liquid state to the gaseous state or vapor state on heating at a constant temperature is called as a boiling. What is meant by boiling? Boiling is a process which is happening when the liquid is changes from liquid state to the gaseous state or vapor state, but at a fixed temperature or at a constant temperature is called as a boiling. And the temperature at which the liquid changes into vapor molecules or vapor without further increase in a temperature is called as the boiling point of the liquid. Means the particular temperature at which the liquid molecules are turning to the vapors and the temperature is never rises or it is not increasing, that particular temperature is called as the boiling point of the liquid. Now we will see the explanation of boiling by the molecular motion. As now let me discuss about the explanation of evaporation by molecular motion. The evaporations occurs at room temperature, but the boiling is happening or it is occurs at a given temperature. That is why in the molecules of liquid, whenever we are giving heat to them, that time the kinetic energy of the molecules are increases rapidly, and because of rapid increase in the kinetic energy of the molecules of a liquid, there is a change of a liquid to the gases is very rapid. So we will see how the boiling is. So we will see the boiling by a molecular motion. Whenever a liquid molecules are given the heat, that time the liquid molecules having the sufficient kinetic energy, means it is having its kinetic energy. So whenever we are giving heat to it, that time the kinetic energy of the liquid molecule is increases, and as the kinetic energy of the liquid molecule is increases, that time the motion of the molecule is also increases. And whenever the motion of the molecules also increases, that time the gap between them is also increases. As much more we will pass the heat to the molecules, that much more kinetic energy of the molecule increases, and that much more speed of the molecule is increases. And as much more speed of the molecule is increases, that much more spaces between them will be increases. At a certain case, when the kinetic energy of the molecule were sufficient, that time we will see the bubbles in the liquids. And when there is a bubbles in the liquid, that time the boiling started. That time the kinetic energy of the molecules were sufficient and they were starting to boil. Whenever the molecules are starting to boil, that time the some molecules are going to the surface and that some molecules are coming to the down or inside. And this process is happening, but at a certain temperature, there is no rise in the temperature. There is no rise in the temperature, but still we can see the bubbles of the molecules and the vibrations of the molecules we can see in the liquid. Then that particular temperature we can say that is a boiling point of the liquid, where the liquid is having the bubbles and the liquid is going to turn into the vapor state. It is into the vapor state. The temperature at which the liquid turning into the vapor, but the temperature is never increasing, it is not increasing. That particular temperature is called the boiling point of the liquid. And whenever we are giving heat to the liquid molecules, that time it is possessing sufficient caloric energy, and that time there is a formation of bubbles in the liquid, and the bubbles is nothing but a boiling of the liquid, and whenever there is a boiling of the liquid, that time the liquid is going to be turned into the vapors form. Now, effect of pressure on the boiling. Now, how the pressure is affecting on the boiling? As much more the pressure is given to the particular liquid, that much more easy to boil the liquid, or to heat to the, or to boil the liquid. As we know that the atmospheric pressure is acting on each and every body, That's why whenever we are boiling to the liquid, that time also atmospheric pressure is also acting on the liquid. And because of the atmospheric pressure, the liquid boils early. If there is no pressure, then it will take more time to boil. If there is a pressure, it will take less time to boil. It means that as much more pressure we given to the liquid, that much more easy, or it is taking more less time, or it is taking less time, less heat to boil the temperature. And as much less pressure, it will take much and more time, it will take much and more heat, and it will take much and more temperature, and that's why the boiling will get less, and it will take more time. We are familiar with the examples. The example is as now we will see about the effect of pressure on the boiling point. So as we are familiar about it, the atmospheric pressure is acting on each and every body. So whenever there is a pressure on a body, or whenever there is pressure on the liquid, as much more we are acting, or as much more pressure will act on the liquid, that much more the boiling point of the liquid will increase. It means that as much more pressure we acted on the liquid, that much more boiling point of the liquid will increase. It means that if it will need a more heat, and it will take more time to boil if more pressure is there, and as much less the pressure, that much less the boiling point will be there. For example, a mountaineers on the mountain. On the mountain there is very less or low atmospheric pressure. That's why the water boils less than 100 degrees Celsius. And it is very difficult to cook on the mountain. And if you will see in the other cases, if you will see the example of a pressure cooker. Whenever we are cooking the vegetables in the pressure cooker, it is taking less time to cook the vegetables. Why? Because the pressure is acting on it, and because of that, at a high pressure, vegetables are boiled very early. Now we will see the next topic of the lesson, that is difference between evaporation and boiling. As we learn in this video about evaporation and boiling, now what are the differences between evaporation and boiling, that we will see. So some differences are as the evaporation takes place at all temperature, while the boiling takes place at a fixed temperature. It means that for the evaporations, no need to give supply, or no need to supply the heat to the evaporation, while for the boiling we have to give heat to it. The second one is what? Evaporations occur only from the surface of the liquid. Evaporation occurs only from or on the surface of the liquid, while boiling takes place throughout the liquid. while the boiling is takes place throughout the liquids. Why? Because we are giving heat to it and it is going from the bottom to the upper. That's why. Now the third one is no need of external heat to pass. For the evaporation, there is no need to give heat from outside, or we have to pass the heat to it. But for the boiling, we have to give heat to it, or it needs external heat to pass. Then the last point is it is a slow process. The evaporation is a slow process. Why? Because it is happening at a room temperature. Why? The boiling is a fast process because we are giving or we are passing heat to it. That's why it is a fast process. This is for today. Bye dear students.